All right, so this is following up from the work we did yesterday. We're trying to remember how to make this trinomial into a perfect square. Now it's called a perfect square because that's what happens when we do the x plus or minus something squared. And since it's squared, that's why it's called a perfect square. Now, inside the parentheses here, that number should be a positive 10 because I take the 20 and I divide it by 10. And to fill in the blank, I do the 10 squared. And 10 squared, of course, is 100. Now, that's the work you did yesterday. It's the work you should be fairly well practiced at as well, which means you can now handle doing something like this. Now, up to this point in what we've done in here, we would not have any technique that would allow us to actually solve this equation. There's a few different techniques that can be used, but we haven't learned any of them. Today we're at least learning one of those, and it's building off of what we just did. So in order to do this, we ask ourselves, what can I put into this side over here to make it factorable? Well, notice that's the same thing I started you with. We need to put in the plus 100 in order to be able to do it. So the very first thing we're going to do is we are going to add 100 to both sides of this equation. And yes, make sure you write that underneath each side. Now when I say each side, I mean each side of the equal sign. So you notice one of those is happening to the left, one of them is happening to the right. So when we go ahead and do that addition now, on the left-hand side, they were just x's. So there's nothing to combine it with, so it's just a plus 100 hanging on the end. On the right side, I can combine it with the 21, so I do the 21 plus 100 to get 121. Having done that, what we technically just did is this is called completing the square. It's called completing the square because we just created a perfect square on the left-hand side, which we can now factor. And of course, you know what that factors to, since that's the same as what we did at the start. That gives us x plus 10 squared equals 121. And having gotten it to that point, this is actually a problem that we solved before, or at least maybe with different numbers, but we've done the same type of thing. Because the next thing we do is we need to get rid of the squared. So how do I get rid of the squared?
Square root.
Square root. Absolutely. And so we take the square root of both sides of the equation. When we do that then, because it equals plus or minus the square root of 121, I have one of them that's x plus 10 equals a positive 11, and I have one of them that's x plus 10 equals the negative 11, to account for both the plus and the minus. And then, of course, in order to finish it out, we solve each of those for x, so that means subtract 10 from both sides and both equations, and you have your answers. X equals 1 and negative 21. And that is the complete process and the new process for today. All right, now we're going to take a look at our other example for today. It's going to be the same process where technically we are completing the square, but this one looks a little different because this one has that plus 20 already hanging out on the left-hand side. But that doesn't actually change how we handle it. Let's start by just looking at this x squared minus 14x. I'm going to be trying to get to a point where I have x plus or minus some number squared. What should that number be inside of the parentheses in this problem? 7, yeah. And so that tells me how I'm thinking ahead. Specifically, it's supposed to be a minus 7, which means that when I square it, I don't want this to be a plus 20 at the end. I want that instead to be a 49. So this is basically what I'm doing, is I'm saying, what do I have to add to both sides in order to make that a 49? Well, 20 plus what is 49? 29. And if you're not sure, you could always have done 49 minus 20 to get that number. Now that we've done that, notice I did that plus 29 again to both sides of the equation, one on the left side, one on the right side of that equal sign. And so it changed the negative 4 as well into a 25. Now I can proceed. I can now do the same process I've done actually many times before. Go ahead and factor on the left-hand side. Remember, I can factor because that's specifically why I chose the 49, was because it was going to make it factorable. and then solve from there. And before we finish it out, the one thing I want you to notice here, why do we do this method? The original equation had both an x squared and an x in it. We can't like divide by x or something like that in order to get rid of the x in that case. By taking it and factoring it into this parenthesis like this, notice it gave us an equation that only has one x in it. So that's why we're then able to solve it to be x equals, whereas we wouldn't have been able to without this method. All right, so to finish solving it out, we get rid of the squared by square rooting both sides. When we square root both sides, we get x minus 7 equals 5 and equals negative 5. So I'm then going to add 7 in both equations. You get your two solutions. X should equal 12 and 2.